Hello everyone in the Whizz Kids Club and welcome to the very first video in our GCSE Maths Made Easy series. In this series we're going to be covering the most challenging maths topics and questions and breaking them down and explaining them in a bit of a different way, a much more visual way so that they're easier to understand and follow along. The first video in this series we're going to be looking at That's right, we'll be looking at the nth term for linear and quadratic sequences. Okay, so it's not as scary as it sounds, but before we can get started, we're going to have to go over some words and terminology so that we're all on the same page. Starting with what is a sequence. So, a sequence is simply a list of numbers that follow a pattern or formula. In the example showing, we can see that each number is increasing by 2 each time. And so by knowing this, we can work out what the next 100 or even 1,000 numbers or terms will be. A term is the value of a number in the sequence, which is identified by its position in the sequence. So for example, the third term in this sequence is 5. Therefore, the nth term is a way of representing any term in a sequence. In this video, we will be going over linear sequences, and in the next video we'll be digging into quadratic sequences. So, to understand linear sequences, let's imagine you're looking at a staircase side on with each step having the same height of 20 centimeters. If we were to write out the height from the ground after each step, it would look something like this. Wait a minute, I think we have a sequence. Let's take a look at it closer. You can see that the difference between each term, which we're going to call the first difference, is the same and is the height of the step, which is 20 centimeters. Now if we were to plot this as a graph, we would get a straight line and thus a linear relationship. So the key ingredients to identify a linear sequence is that the first difference is the same between each term, and we get a straight line graph if we were to plot this. We have seen an increasing linear sequence where the sequence starts with a small number and gets bigger. However, we can also have a decreasing linear sequence where the numbers get smaller with each term and the difference is subtracting from each term or a minus number. If they don't follow this pattern, then there may well be a quadratic sequence, which we'll cover in the next video. The formula that defines a linear sequence is an plus or minus b, where a and b are numbers and a is the value of the first difference. Small side note, this formula applies to both increasing and decreasing linear sequences, and the value of a can be positive or negative. I'm going to show you two different methods to work out the formula for a linear sequence. The first is a more detailed method and the second is super simple, but it helps to understand the detail before you can jump to the second. So let's take a look at an example. Straight away we can see that this is an increasing linear sequence as the numbers are getting bigger with each term. The first thing we need to do is work out the first difference between the terms, which we can see here is plus 7. This is the value of a in our formula, so if we plug that in, we can see that the sequence will be related to 7 times n. Let's write out 7n as a sequence. Now we can see that this is different to the original sequence, so this means that we need to work out the value of b to bring the 7n sequence to match the original. If we look at the difference between each of these terms and the sequences, we can see that we need to minus 5. Therefore, this is the value of b, and so the formula for this linear sequence is 7n minus 5. Now that's all well and good, but I'm going to show you a really simple and easy way to work this out for both increasing and decreasing sequences. The first part is the same as we did before. We need to work out the value of the first difference of the sequence. Then we need to remember this number and the first term in the sequence. Now draw a big letter L, which stands for linear, with an arrow on the short end pointing to the number we want to work out, which is the first term in this sequence. At the top of the L, write down the value of the first difference. And so what we need to do is work out how we get from the top number to the bottom number. And in this case, we need to subtract 5 from 7 to get 2. The top number is the value of A, and the corner number which we worked out is B. We can substitute this into our formula to get, again, 7n minus 5. Great, now it's your turn. Try to find the nth term for the sequences below and look out in the description for the answers. I hope you found this helpful. Please give a like and subscribe for more Maths Whizz videos, and stay tuned for the next video which will be covering the nth term for quadratic sequences. Peace.